Hello everyone, I am Pariskhit and welcome to another exciting session on Unacademy CAT-alyst. In today's session, we are going to actually see some of the best strategies to solve LRDI caselets. I'm going to introduce a never seen before approach. A lot of you often find Venn diagrams actually frightening, and especially if they are related to maxima minima Venn diagram questions. So today I'm going to show you how to solve Venn diagram questions by just drawing straight lines. So stay tuned for this exciting session. But before always, the first thing that I'm going to tell you is give me 10 seconds to ensure that I'm streaming live before we get started with the session. Okay, I think we are streaming live and we are good to start. Let's get started. Okay, in today's session, right, we are going to talk about some of the best strategies to solve LRDI section. Now, I have taken a lot of videos detailing out how to select caselets, whether to solve LR or DI first, how many rounds should you take, which type of questions should be solved, and a lot of other similar important questions which are already available. But in today's session, what I'm going to talk about is basically a strategy, a super awesome strategy, I would say. A super awesome strategy which can help you to solve any Venn diagram question. A super awesome strategy in LRDI to solve any Venn diagram question. Venn diagram. I believe that a lot of you often find this concept very difficult. Venn diagrams. So I'm going to focus exclusively on Venn diagram, and for strategies to tackle the LRDI section, you can always look at my other videos. So let's get started immediately on how to tackle Venn diagrams in LRDI section. Okay. Supposing you get a Venn diagram question, something like this, right? Now let's read the question. In a school of 100 students, each of them plays at least one sport among cricket, football, volleyball, basketball, hockey, and tennis. So as you realize, there are many variables: cricket, football, volleyball, basketball, hockey, and tennis. So how many variables are we talking about here? We are talking about actually 6 variables. So whether it is 3 variables or 4 variables or 2 variables, the concept remains the same. So the method that I'm going to show you will be applicable for not only 6 set Venn diagrams, but even a 2 set or a 3 set Venn diagram. Okay. It is known that exactly 90 play cricket. So let's write down the numbers. 90 is cricket, 80 is football, 70 is hockey, 60 is basketball, 40 is volleyball, and 10 is tennis. Now remember, in Venn diagrams, you must have seen in your books what they do. They draw circles. They draw circles like this. They draw circles like this. Have you ever wondered why do they draw circles? Why they cannot draw some other diagram? So it is with this thought that I actually want you to bring in something new. Let's not draw circles today. Let's just draw straight lines. Let's just draw straight lines. So each circle can be represented in the form of a straight line. Each circle in the form of a straight line. Okay? Because in that way it becomes very easy to solve a caselet. Okay. Now what I want you to imagine is there are 100 students as per the question. So I want you to imagine 100 students are standing in a queue. 100 students, let's say, take an example, are standing in a queue. Okay. For the first game, how many students do I need? I need 90 students to play the first game. So it can be any 90, right? It can be any 90. So let's say I ask roll number 1 to roll number 90 to play the first game. Okay. I am asking, this is question number 1 that I am solving. Roll number 1 to roll number 90 to play the first game. Next, 80 students. I need 80 students for the second game. Remember, question number 1, what is it saying? It is saying, what is the maximum number of students who play exactly 4 of the 6 games? Exactly 4 of the 6 games. 4 out of 6. You need to maximize this. Remember, if you were to draw circles, it will be very difficult. So what do you do? Just draw lines. Just draw lines. How will you draw the lines? You draw lines in such a way that exactly 4 lines overlap. You draw the lines in such a way that exactly 4 lines overlap. How many lines you need to draw? You need to draw a total of 6 lines. A total of 6 lines in such a way that 4 lines will overlap. Let's draw the second line. I need a line of 80. How many students for the second game? I have just noted down the numbers. 80 is playing football. So I need to draw a line of length 80. Okay. Remember, draw the line in such a way that they overlap. So I will draw it from this end. I will draw it from this end. 1 to 80. Perfect. Third one. The third game, 70. I need 70 students to play the third game. 70 students. So again, draw the line in such a way that the lines are overlapping. So obviously I will draw it from the left end. So it is 70. 1 to 70. Next, 60. I need for the fourth game, 60. Draw the line in such a way that it overlaps. So basically 60. 1 to 60. Now think about it. Now think about it. Please try to visualize. What do you want to try to visualize? You see here, roll number 1 to 60 is now playing exactly 4 games. Can you see this? Roll number 1 to 60 is exactly playing 4 games. And that is what the question was asking me. I need to maximize students who play 4 games. And you see 1 to 60 is playing the first game, second game, third game as well as fourth game. So at this point, do not touch roll number 1 to 60 again. Do not touch. I repeat, do not touch. Why? Because they are already playing 4 games. So I'll just take a note of it. Roll number 1 to 60, I'm not going to touch them because they are already playing 4 games. Next, what is the fifth game all about? How many students I need? I need 40 students. 40 students. Now you know what? Roll number 1 to 60 do not touch, because if you touch them, they will be playing 5 games. Now I need to draw a line of 40 units. I need to draw a line of 40 units, but not from 1 to 60. Why? 1 to 60 already 4 games. So where can you start from? You can start from 61 to 100. 61 to 100. Right? Now visualize. Now visualize. If you are visualizing, you see 61 to 70. 1 game, 2 games, 3 games, 4 games. Perfect. 61 to 70 is also playing 4 games now. So what do? Do not touch roll number 1 to 60 because they are already playing 4 games. Perfect. Then you need last game 10 students. Remember, you cannot touch 1 to 70 because if you touch them, they will be playing 5 games. The question only wants you to play 4 games. So 10. Where will I start from? 71 to 80. 71 to 80. Now can you see? Now can you say, is there any other set which is playing exactly 4 games? Yes. 71 to 80. 1 game, 2 game, 3 games, 4 games. Perfect. So 71 to 80 is also playing 4 games. So what's your answer? Your answer is 80. Did you get it? So the point here is you can easily replace the circles in a Venn diagram with lines. You can easily replace the circles in a Venn diagram with straight lines. You need to draw the lines in such a way that many lines will overlap. Like in the first question, they said 4 of the 6 games, maximum 4 of the 6. So draw lines in such a way that 4 lines overlap out of the 6. Do you get the point? We are doing more questions, so you'll get comfortable with this approach. This is a super awesome technique and you will be able to solve sums within minutes. Very, very difficult caseless. Let's look at the second question. Let's look at the second question. Okay. Let's look at the second question. Okay. Now, second question talks about maximum 5 of the 6. Maximum 5 of the 6 I need to play, right? I need to select students in such a way that maximum 5 games are being played by the students. So it's very simple. Again, the logic is this time you will draw the lines in such a way that exactly 5 out of the 6 lines will overlap. Exactly 5 out of the 6 lines will overlap. Exactly 5. Let's draw. First line, 90 units. So absolutely no problem. 1 to 90, I can draw a line. Second game, how many students? 80 students. So you need to draw the lines in such a way that they are overlapping, meaning that they are drawn from the same point. So same side, I would say. So again, you see 1 to 80. Do not lose focus on the big picture. The big picture is you need to draw 5 lines. You need to draw 5 lines in such a way that they are overlapping. Come back to the third point. How many students are required? 70 students are required for the third game. Again, draw a line. Just draw a line. Next. How many students for the fourth game? Remember, 60 is playing basketball. So I need 60 students. So draw a line in such a way that exactly 60 students are playing the fourth game. Next. How many students? 40 students. 40. So 1 to 40 this time. 1 to 40. Now take a pause. Now take a pause and count. How many lines have you already drawn? See, 1 to 40. 1 to 40. Can you have a look? 1 to 40 is now playing 5 games. Can you see? It is exactly overlapping 5 regions. Can you see? 1 to 40 is common for the first line, second line, third line, as well as the fourth line and the fifth line. Perfect. It means 1 to 40, roll number 1 to 40 is now playing 5 games. Roll number 1 to 40 is now playing 5 games because there is overlap of 5 games. Now, do not touch 1 to 40 again. Do not touch 1 to 40 again. Why? They are already playing 5 games. So what happens? Now you have another one left, right? You still need 10 students to play the last game. What is that game? Tennis. Now do not touch 1 to 40. Why? If you touch 1 to 40, it will be 6 overlap. And if there are 6 overlap, it means they are playing 6 games. So don't do that. Question is asking 5. So don't touch 40. So from 41, you can touch from 41. So 41 to 50. 41 to 50. Can you count now? How many games 41 to 50 is playing? 41 to 50 is playing 1 game, 2 game, 3 games, 4 games, 5 games. And that is what the question was asking you. The question was asking you maximize 5 of the 6. Awesome. So even 41 to 50 can be included. So what's your answer? Maximum how many students can play 5 of the 8 games, 5 of the 6 games? Answer is 50. Did you get it? So do not try to draw the circles. The circles are just notations, right? These are just diagrams in a Venn diagram. These are just the diagrams. Why not replace the circles with straight lines and get your answers? That is the beauty of mathematics. You can draw any figure, you still come up with the same answer. Let's look at the third question. Let's look at the third question. Remember, any type of question, maxima, minima, in a Venn diagram can be solved using just lines. Let's look at the third question now. The third question. Okay. Now, third question is a bit different. Why it's a bit different? First of all, it is a bit different because they are asking you what? Minima. They are not asking you maxima. Okay. Not a problem. It's the same logic. Cricket, football and hockey. Can I take the corresponding numbers? 90 are playing cricket. Football 80 are playing football, and hockey 70 are playing. You know what? I need to minimize this 3. I need to minimize people who are playing 3 games. Let's draw it. Let's draw it again. So what will I imagine? Remember, there are a total of 100 students. So my imagination will be there are 100 students who are standing in a queue. 100 students are standing in a queue. Let's say from roll number 1 to the very last roll number 100. Now, I am the principal, so I'll have to ask 90 students to play, let's say, cricket. Okay, doesn't matter, it's the first line, doesn't matter. Any 90 can play. So, you know what? I will ask roll number 1 to 90 to play the first game. Roll number 1 to 90 to play the first game. Now, remember, the key word here is minimum. The key word here is minimum. So, when I say maximum, you need to draw the lines in such a way. Maximum means what? Maximum, if they ask you, overlap. It means you need to draw the lines in such a way that the lines are overlapping. If the question changes to minimum, what will happen? No overlap. There should not be any overlap. That's it. As simple as that. Maxima, overlap. If the question is asking you minima, no overlap. So draw 3 lines in such a way that the 3 lines do not overlap. Simple. Let's take the next number. 80. Remember, they are asking me to do minimum. So I want to draw the lines in such a way that they don't overlap. So very simple. Where will you draw the line from? From the right hand side. From the right hand side. Can you see this? I can draw the line from this side. Why? Because I don't want the line to overlap. What is the length of the line? 80. Length of the line is 80. So 80 means 21 to 100. Length 80 means 21 to 100 would give me a length of 80. Right? Next, the third one, 70. How much? I need to draw a line of length 70 units. Remember, you need to draw the line in such a way that the line doesn't overlap. So where can I draw? Where can I draw? Can you visualize? 70, right? Can I say this part I can draw? I can draw a line in this part. Why? This part is empty. Can you see this? This part is empty. So I can draw a line at this point. At this point. Will you agree? No overlapping. Remember, no overlapping. Any other free space? Yes, there is some free space out here as well. Can you see this? There is some free space out here. Why? This part is empty. Remember, it's a line. It need not be a continuous line. You can break the line. 20 on the left, 20 on the right, 10 in the middle. It's just a line. So can you see this? This space is empty. So wherever there is empty space, just utilize it to draw the line. Just utilize it to draw the line. Let's draw the line now. 70, right? So here, this is empty. So I can use 1 to 20. Why? Can you see this? This portion is empty. So I drew a line of length 20 units. Next, anywhere there is empty, anywhere that thing is empty, yes, this portion, there is something empty. So again, I can utilize it to draw a line. How much? 91 to 100. Do you get it? So how much is gone? 1 to 20, 91 to 100. So 30 is already gone. 30 is already gone. Remember, the total length of the line should be 70. The total length of the line should be 70, out of which 30 is already done. Remaining 40. Think about the remaining 40. Now the remaining 40 doesn't matter. Wherever you draw it, absolutely doesn't matter, because I don't have a choice. I might wish to draw it here. I might wish to draw it here. But the bottom line is, these lines will exactly overlap. There will be overlap of 3. There will be overlap of 3. So wherever you draw it out here, you draw it out here, doesn't matter. Wherever you draw at this point, you know what? There will be overlap. There will be overlap. So I don't have a choice. I need to draw a line of length 40. Wherever you draw. So let's say I drew it here. I drew it here. Let's say here. So how much? 21 to 60. Remember, out of 70, 30 has already been drawn. So I need to draw a line of length 40. Length 40. So now if I ask you, where is the minimum overlapping? Minimum overlapping of 3, right? Because the question was asking cricket, football and hockey. Minimum overlap of 3. Which is that part? This is that part. Can you see this part? This is that part. This is that part where there is an overlap of 3 regions. And hence minimum, how many students? 21 to 60. When I say 21 to 60, total count is 40. 40 students are playing minimum 3 games, and that's the answer. 40 students are playing minimum 3 games, and that's the answer. So I think there is a very good learning out here. The learning is, whenever you get maxima, minima questions in a Venn diagram, try to solve it by just drawing lines. Ask yourself, why do we draw circles? Can we not draw squares? Can we not draw rectangles? Can we not just draw lines? And probably lines is the easiest geometrical figure. I won't say figure, geometrical figure probably is, yeah, it's a geometrical figure only, right? So the easier geometrical figure is a line. So replace a circle with a line and try to solve a question. Remember, at the end of the day, CAT 2020 LRDI is just 40 minutes. You cannot be taking 15 to 20 minutes to solve one sum. Even if you know how to answer it, you cannot be taking 15 to 40 minutes. So this is a super awesome strategy. A super awesome strategy to tackle Venn diagram questions in the LRDI section. So I believe I have made sense out of it. Please practice more questions. It need not be a 6-set Venn diagram. It need not be a 5-set Venn diagram. Even for a 3-set maxima minima Venn diagram, you can apply the method that I just showed you. So can I summarize? The summarizing is, if it is maxima, draw the lines in such a way that they overlap. If it is minima, draw the lines in such a way that they do not, I repeat, do not overlap. Got it? Got it? So I think that's what talks about maxima, minima in a Venn diagram. And if I were to talk about CAT 2020, remember we are looking at 5 to 6 sets. 5 to 6 sets this time in your LRDI section. Most probably, this is what all experts believe. And out of the 5 to 6 sets, we are looking at you solving correctly around 3 to 3.5 sets. So total sets is 5 to 6, and how many you will target is somewhere around 3 to 3.5 sets is what you will target. When I say target, you mean you will solve it correctly. The assumption here is the difficulty level of LRDI is the same as the last 2 years. So if the difficulty level is the same, this is what your target is going to be. If the difficulty level changes, okay, or it becomes harder, obviously number of correct attempts will come down, and vice versa. If the paper is very easy, this number of attempts will go up. But if the difficulty level is same as 2019 CAT paper and 2018 CAT paper, we are looking at probably out of the 6 around 3 sets or around 3.5 sets for a 99 plus percentile. So I think you understood today. Please revise the video once again if required. Once you have done seeing the video, please try to solve the same sum yourself, and then you will get the confidence. So thank you so much. I hope you enjoyed today's session, and I will see you tomorrow morning 10:30 a.m. again for another super awesome session on LRDI for the CAT. Till then, take care, and if you have liked the video, do please hit the like button. That motivates me to make more and more videos. Thank you so much, and I'll see you tomorrow. Stay safe.